So continuing our lessons in the product of primes or using prime numbers, we're going to talk about fractions a little bit. So fractions, for example, 3/5, just a rational number, a fraction that we work with every day. But what if I were to multiply this number by the number 1? 3/5 times 1, what does that equal? Well, 3/5 times 1, anything times 1 is just the same thing again, 3/5. Okay, easy peasy, nothing new there. But we also happen to know that the number 1 can be written as 2/2, for example. Isn't a fraction that has the same numerator and the same denominator just equal to 1? You take one pizza, you divide it into 2 pieces, you eat 2 pieces. How much pizza did you eat? The whole thing. So 2/2 is a way to say 1, just another way to say 1. So this time if I multiply 3/5 by 1, still doing the exact same thing, 3/5 times 1, 1 is just written differently in this case. Well, multiply fractions, multiply across the numerator, 3 times 2 is 6. Multiply across the denominator, 5 times 2 is 10. And so I get 6/10. Now, 3/5 and 6/10 don't really look the same, but it turns out they have the same value, and they have to have the same value because if I multiply 3/5 by 1, anything times 1 equals itself. They look different, but they're the same amount. They're both 3/5. They just look different. We call that equivalent. We don't call it equal because even though they are an equal value, they're not the same thing. They don't look exactly the same. They both represent the same number. So we just call it equivalent, meaning equal-ish. Well, okay, that's not fair. Meaning equal, but just not saying equal because they don't look the same. And so we want to express that. So two fractions can be determined to be of equal or equivalent value if they both reduce to the same number. For example, if, let's see, I have 5 halves. We want to know, is 5 halves equivalent to 25/10? Well, how would we be able to determine that? And this is where products of primes comes into place. So I want to write both fractions as a product of primes. So if I looked at the left-hand side, I have 5 divided by 2. These are prime numbers. 5 is already prime, 2 is already prime. That's all I can do on that side. On the other side, not the same though. 25 could be written as, well, the biggest prime that divides 25 is 5, leaving 5, and 5 is prime. And then the biggest prime that the smallest prime that divides 10, and I meant to say that here, the smallest prime that divides 25 is 5, leaving 5. The smallest prime that divides 10 is 2, leaving 5, and 5 is prime. So notice, up here, when I multiplied by 2/2, 2/2 is actually just the number 1. So what we can do when we have numbers written as products of primes, we can cancel. 5/5 just equals 1. So all I'm doing is multiplying 5 halves times the number 1. So I can write it as a 1. And you know, in algebra, we often don't write 1 because it's trivial. And so this is called canceling. So when I cancel the 1 out of the fraction on the right-hand side, I'm left with 5 halves equals what's left, 5 halves. And so I can say that in fact, 5 halves is equivalent to 25/10. They both represent the same number value, 5 halves, but 25/10 just look different. Okay, so these are equivalent fractions because they both reduce to give you the same number. And in this case, of course, the numbers are fractions, not integers. So another way to look at this for equivalent fractions is suppose I'm given some other fraction. So suppose I have, let's see, 6/7. Okay, that's a perfectly good fraction. What if I wanted to write 6/7 as an equivalent fraction? I want to write something equivalent for 6/7. Well, there are a billion choices. Actually, there are more than that. There are infinity choices, but a billion is a pretty big number too. So if I were to multiply 6/7 as I did up here by some representation of 1, so I have 6/7 times, what if I multiply by 4/4? Aren't I once again just multiplying 6/7 by the number 1? Of course I am. So now if I multiply across, 6 times 4 is 24, and 7 times 4 is 28. So I can say that 6/7 and 24/28 are equivalent fractions. Let's do some examples. We want to write two different fractions that are equivalent to 15/18. 15/18. Okay, so the easiest possible one, obviously, is just to multiply by 2/2. Well, the easiest one would be to multiply by 1/1, but that just gives me the same fraction. And so we want to multiply by something, some expression of 1, in this case 2/2, to get an equivalent expression of 15/18. So multiply across, 15 times 2 is 30, and 18 times 2 is 36. So 15/18 and 30/36 are equivalent fractions. Cool. I think I'm going to do it a different way for the second example because it did ask for two fractions that are equivalent. This time I'm going to multiply by 1/3. What? What does that mean? Well, I can multiply by anything as long as I do the same thing in the numerator and the denominator. So 15 times 1/3, which is really the same thing. Let's look at that more closely. And you should remember this from earlier math, but let's just be sure. 15 times 1/3, if I multiply that across, that's the same as 15 divided by, so remember this 15 is really over a 1. We just don't write it unless we need to. 15 in the numerator divided by 1 times 3 in the denominator. So 15 times 1/3 is really the same thing as 15 divided by 3. Crazy, huh? So let's do 15 times 1/3, which really just means divide by 3, and 18 divide by 3 then equals 15 divided by 3 is 5. And 18 divided by 3 is 6. So I can say that 15/18 is equivalent to 5/6. Something else that might just blow your mind a little bit is if 15/18 is equivalent to 30/36 and 15/18 is equivalent to 5/6, that means that 30/36 is also equivalent to 5/6. They all equal the same thing as 15/18. Crazy, huh? All right, I want to look at this one just a little bit more closely. All right, so I'm going to take this one over here, and I'm going to look at it as 15/18, and I'm going to do this method on it now. So 15 times 18, if I write each as a product of primes, well, 15, the smallest prime that divides 15 is 3, leaving 5, and 5 is prime, so I write it down. Divided by the smallest prime that divides 18 is 2, leaving 9, which divides by 3, leaving 3, which is prime, so I write it down. So now watch what I can do. I'm going to cancel these two 3's because 3 divided by 3 equals 1. Notice what just happened. Remember, prime numbers or product of primes, or excuse me, factors are all about what divides a number. So when I can divide a number by 3, it means that 3 is a factor of 15. 15 divides by 3 because 3 is a factor of 15. 18 divides by 3 because 3 is a factor of 18. And if they're factors in a fraction this way, then the two factors form the number 1, and I can cancel them. So really, dividing by 3 from the numerator and the denominator is the same thing as canceling common factors. So if I write it as a product of primes and cancel all the common factors, and notice that's it, there's no more common factors, then when I write what's left, 5 over 2 times 3 is 6, I've written the simplest form. So this is called the simplest form. So the simplest form of a fraction is the fraction that has all the factors that are common in the numerator and the denominator canceled out, and whatever's left is the simplest form of the fraction. So let's look at another example of that. Let's write 25/40ths in simplest form. So 25 over 40 in simplest form. Let's write it as a product of primes in the numerator and then the denominator. Smallest prime that divides 25, other than the trivial case 1, is 5, leaving a 5, so I write it down. Smallest prime that divides 40 is 2, leaving 20, which divides by 2, leaving 10, which divides by 2, leaving 5, so I write the 5 down. Common factor, right here, so this is really just the number 1. Cancel the 5s, and what I'm left with is 5 in the numerator, and 2 times 2 is 4, times 2 is 8 in the denominator. And so the simplest form of 25/40ths is 5/8. Notice the simplest form of a fraction doesn't have to have prime values in both the numerator and the denominator. I happen to have a prime number in the numerator here, but 8 is a composite number. And so for simplest form of a fraction, I'm not necessarily going to end up with primes like I did in my first example on 5/2. So let's do a last example, and this time, because it's pre-algebra we're dealing with, we want to work with monomials. So we want to write the number 16bc cubed, ooh, that's already big, and I'm not even done yet, divided by 24b squared c. All right, so we want to write the simplest form, and we're going to do that by finding an equivalent fraction, an equivalent value that has all of the common factors canceled out of it. So let's go ahead and write this as a product of primes, which is exactly what we already know how to do with variable expressions or variable numbers. So in the numerator, I've got 16 divides by 2, leaving 8, which divides by 2, leaving 4, which divides by 2, leaving 2, which is prime. And then the denominator, 24 divides by 2, leaving 12, which divides by 2, leaving 6, which divides by 2, leaving 3. And 3 is prime, so I'm going to write it down. Now in the numerator, let's deal with the variables. Well, I have 1b, so I'm going to write it down. And then I have 3c, so I'm going to write them down separately. In the denominator, I have 2b's. And I have 1c, so I'm going to write it down. All right, so now I've written the numerator as a product of primes and the denominator as a product of primes, and now I'm going to cancel like terms. Now, notice how when I cancel, I make these cancellations look like the number 1. In this case, that's just to make the teaching example. We don't actually do that. We just cancel by canceling. 2 cancels with 2. 2 cancels with 2. 2 cancels with 2. 3 cancels with 3. Wait. 2 doesn't cancel with 3, done. Sorry. 2 cancels with 2, 2 cancels with 2, 2 cancels with 2. B cancels with B, and I have a C that cancels with a C. And so what's left? In the numerator, scanning across, I have a 2 times C times C. So I have a 2 and 2 C's. And in the denominator, I have a 3 and 1 B. And so now I've written the monomial in simplest form, and the original fraction and the simplest form fraction are equivalent. So these have the same value.